Good morning, everybody. Good morning. Good morning. Welcome to another spring showcase. Today we're partnering with MGISS and Northumbrian Water to find out how they've worked collaboratively to identify potential encroachment and avoid buildovers on strategic assets to minimise risk and residential and commercial customers. My name is Chloe Tooth and I am the Knowledge and Communications Manager here at Spring Innovation. For those of you who might not already know, we are the Innovation Centre of Excellence for the water sector, supported by all the water companies across the UK and Ireland, as well as the supply chain and academia. We're here with the goal of enabling collaboration, removing duplication, and accelerating innovation in the water sector. So we at Spring are the custodians of the Water Innovation Strategy 2050. For anyone that hasn't seen that document, we're going to pop some links to the chat to that in a second. And that lives on our website. It has 7 themes with challenges that sit under those themes that we want to be solving within the sector. So we also put out calls for innovation against those themes through our Spring Accelerators, and you can find out more about the current Spring Accelerator 3 programme through our website, and there'll be a link to that in the chat also. But today's service offering is about knowledge sharing, so we have 2 aspects to that. The first being our knowledge library on our Spring platform, where there's a bank of over 60 case studies for you to go and learn from and utilise on innovation projects from across the sector, with over 200 more case studies currently in the pipeline. So this is constantly being updated, so please do go over and check that out and register, and there'll be a link to that, like I said, in the chat also. For anyone that might not be able to stay all the way through or wants to share this with any of their colleagues, the showcase recordings for a number of those projects and any supporting links or documents, as well as today's showcase, sit alongside those case studies. So for anyone that wants to go back and refer to that, that will be available on the Spring platform also. So this is a 2-hour knowledge showcase event, and we're happy to see that there's lots of people registered for today's event, and specifically some people from India, Israel, and New Zealand. So welcome to the call, and thank you so much for joining us. Today's attendees can expect to gain insight into the successful completion of the technical and commercial feasibility stage of their ESA supported risk alert service, and find out how, by leveraging AI with change detection algorithms and combining these with strategic network records, Northumbrian Water were able to gain new insights to manage risk associated with network disruption. So this is showcase number 24 for Spring, and with over 3,575 people registered for these events, we're super happy and really proud of how these are helping to disseminate knowledge from these innovation projects and accelerate learning across the sector. So these showcases are all about being able to learn a little bit more about the project, taking away those learnings and that knowledge and being able to embed them in your organisation. So this being said, we will be launching a poll at the end of this showcase to find out how interesting you found the information, and also whether you're going to hoping to go away and use that afterwards. So please do submit your answers at the end of this event when that comes through. So on to today's session. I'm just going to run through the agenda quickly and introduce our speakers before I hand over to Angela to kick off this showcase. So in terms of the agenda, like I said, we're going to introduce those speakers. We're going to go into an importance of knowledge sharing and the IPAS project, the value of the IPAS to Northumbrian Water, the IPAS pilot project in operation at ESW. We're going to go into a short break and then into the lessons learned and the future for IPAS, and then into a questions and answers session at the end. So for you, any of you that have got any questions as we're going through, if you want to pop those in the chat, the team will do the best to answer those all at the end of the session. And if there's any that do go unanswered, they also will be uploaded alongside the recording of the showcase and the case study on the Spring platform as well. So without further ado, I'm just going to introduce our speakers. So next up, we've got Angela McCusker, Head of Innovation from Northumbrian Water Group. Then we've got Clive Sermon-Wells, Innovation Partnerships Manager at Northumbrian Water Group. We've got Mike Cooper, Strategy and Innovation Manager at MGISS. We've got Darius Miramadi, Product Manager at MGISS. And we've got Adam Loudell, Strategic Network Manager at Essex and Suffolk Water. So I think it's time for me to hand over to Angela for the next part of the session. Thank you.
Good morning, everybody. Great to be here on this knowledge sharing session. And really, all I'm wanting to do is just really emphasize why knowledge sharing in this space is so important. And we really value the service that Spring are putting on for us to allow us to disseminate innovation information across our sector and beyond to make sure that it drives the maximum value that it can. So first of all, we have a brilliant opportunity given to us through the Ofwat Innovation Fund. So far, they've supported and funded over 70 different projects. And this is 70 odd different opportunities for us to learn about different aspects of the innovation in the water sector and really embrace those learnings. These could be positive learnings in things that we actually want to adopt and roll out across the sector. They could also be things that perhaps haven't gone quite as well. And there are always really brilliant lessons to be learned when things haven't gone according to plan. And we can all do shortcuts and really augment the learnings that we have in our individual organisations. Secondly, Sprint are doing a brilliant job sharing it in this format. It's recorded so people can go back and reference to it at a different point. So please do share this around your colleagues, around people in your business to make sure that we can maximise these learnings. And ultimately, we are all running these innovation projects to make sure that our products and services are resilient and reliable for our customers now and into the future. And really, we're wanting to get the most value for money for our customers. And this is one way in which we can really drive that value from innovation by sharing this knowledge and really embracing all of these brilliant learnings. So really, if you're not doing that, you're missing out, and so are your customers. The other thing that happens when you attend events like this and actually take that valuable time from your day job, which I know everybody's to-do lists are really big, but when you do invest in time like this, what it'll do is not only will you learn all of the great stuff that's happened in these projects, but it will also spark other thoughts and ideas in your mind and maybe stoke some curiosity. So it might even manifest itself in a different way or on a different project, but having that time out really allows yourself to think a little bit deeply about different things. And secondly, we really need to make sure that this is disseminated far and wide. So please don't keep this to yourselves. Share it with colleagues and make sure that you do really put the information out there. Collaboration is really, really important here. So you'll meet people on this call today or see names and hear people that you think could be useful to tap into. So please do reach out. I know we're very collaborative at Northumbrian Water. We have our Innovation Festival, which you can see I'm proudly sharing here, which is happening the week of July 8th. And we very much open our doors for people to come on board. And MGISS have been partners who have done that routinely over the last 8 years in which we've been doing this. We absolutely, really value the partnership that we have fostered with MGISS. And really, they've brought a capability into our business that we didn't have before. So by having these opportunities to collaborate, really do spark new ideas and result in really brilliant projects like the one that you're going to share today. So without further ado, I'm going to hand over to Clive, and I really hope that you take the most out of this brilliant knowledge exchange. Thank you very much.
Thanks very much, Angela, and I am likewise delighted to be here at this Spring Showcase talking about a project which we've been involved in for a number of years and very proud and pleased to be involved with. So if we can move along to my next slide, that's fine. I'm just going to be talking briefly about the rationale for this project and what it is we're trying to do and why we're trying to do that. So based in Durham, Northumbrian Water provide over 1 billion litres of water every day to our customers across the northeast of England through Northumbrian Water, and in the east of the country operating as Essex and Suffolk Water. The water is delivered through a network of 25,000 kilometres of water pipes, which is broken up into multiple parts. It's the strategic part of the network. If we go back to the previous slide, it's delivered through what we term trunk networks or strategic networks, which are generally large diameter pipes, but they can be designated as strategic networks because of their purpose or function or their criticality to the network. And they are 4,200 kilometers of this strategic network delivering water around to the extremities of the network. So it is a vast network. Let's move on to the next slide. So managing and monitoring and protecting, importantly, this strategic water network to ensure there are no interruptions to supply is absolutely crucial. Every day we face threats to supply, but amongst the most concerning to the strategic parts of the network are accidental utility strikes. And you can just see sort of faded into the background. This is an actual example of the impact of an accidental utility strike where a contractor a third-party contractor was working on the power and accidentally hit a water main, and the consequences of that are quite devastating to this area. But we're also at the other main area is buildovers, where something's built on top of a strategic asset without going through the proper checks and authorization. So one of the key problems is that we sometimes don't find out about this until it's too late. Let's have a look at the next slide. Managing, monitoring, and protecting the strategic network is challenging, though, because the sheer scale of the network, it's absolutely vast at 4,200 kilometers, and it's geographically dispersed across quite a large area. You'll remember from that first slide. Traditionally, we've walked the whole of the strategic network every 18 to 24 months, but it's incredibly labor intensive, and it's just not feasible with current methods to sweep as frequently as we'd like to. Obviously, that's not going to pick up everything that's happening on the network going that frequently. Even if we could have eyes everywhere to spot encroachment early enough to avoid problems, we'd still have the challenge to prioritise which ones we should deal with first. Using a helicopter contract to fly the lines every 2 weeks, as they do in gas, would be very expensive, and also, of course, has quite a high carbon impact. And the buffer zone either side of the strategic main needs to be quite wide as well, because we're not just looking at what's happening directly on top of the strategic mains. We want to know what's crossing over. If there's works very, very nearby, then it could mean very heavy transport crossing the main repeatedly, which could cause problems. Let's have the next slide. So how do we do this at the moment? What have we considered? Well, periodically and not too frequently, we walk the course of the strategic water mains, but it is really too infrequent and of limited range to be of use. Becoming aware through responsible third parties contacting us for plans and then letting us know. The thing about this is you only really know what you know. You don't know the unknown unknowns. So what I mean by this is, if a third party comes forward and tells us that they're going to be doing some work, we can go out and take all necessary actions and inspections to ensure there's not a problem. But if they don't tell us, we simply are unaware that these things are going on or very nearby our strategic networks. Another way is staff sometimes spot things in the course of business as usual routine. They happen to be passing by, but it's a very hit and miss to rely on that as your means of understanding what's going on. Now, I've done an elephant next to the picture of the drone here because it is a little bit of an elephant in the room, and we often hear, well, why don't you just use drones to do this? Well, drones are now being used more widely, but the current visible line of sight restrictions are very limiting it. And you've also heard the scale of the network at 4,200 kilometers every 2 weeks. It just doesn't lend itself to this technology, we don't believe anyway, at this stage. It's the sheer scale that makes this unfeasible. Let's have the next slide. If we could specify what we actually need to address this challenge, the kinds of things that we would say if we were describing it would be, well, we want a much more proactive approach, something that alerts us to suspected third-party encroachments on the strategic main and the buffer zone and easement zone across a huge geographical area. just as early in the construction process as possible, so that we can intervene before anyone has spent a lot of money building something. And we want to minimize the false positives so that we can really target where we send our field crews to have a look. Ideally, something where we can pick and choose which mains are being monitored, and we can change that and extend the scale very, very rapidly, ideally from a desk. And ideally with some form of prioritization that's based on a confidence factor that something really is going on, because you don't want to be sending a resource pushed team out to places where actually we didn't really think then there was anything going on there. Okay, next slide. We've got numerous examples to draw on. Here are a couple of examples where we've had build-overs and we've been notified basically too late, after something has either already been built or the excavation's already happened and someone's found something a bit like an unexploded bomb and then had to make contact with us. But it's not just about somebody building something directly on top of a strategic main. In Central Park in Romford, they built an outdoor auditorium and to create the acoustics, they had to dig a very large excavation and excavations, both large and deep. Earthworks can radically change the depth, either by removing topsoil or by dumping it in large mounds, in this case 4-metre high mounds. That meant our strategic mains were now much deeper than they had been before. Let's have a look at the last slide I have to present, which is that the costs can often be recovered. So if we're, I guess if a utility strike happens, then usually there's a throttleable neck there. We can find out who did it and we can negotiate with them to have the costs compensated and the repair takes place. But that isn't where the main costs are, believe it or not. They are spread around multiple areas. If at the end of the day there is an interruption to supply, customers are very rarely interested in who actually caused it. They will look to us. The reputational damage will be to us. Time spent dealing with encroachments after they happen is time we could have been delivering customer value-added work. It's unnecessary wasted time, and things always take longer afterwards if you catch them later in the process than if you plan them in. The legal expenses can outweigh the redirectional costs, and some legal time is often required regardless of the outcome of the incident. We may not even be able to recover the costs in some instances. So those are the main areas of cost to us. So at this point, sort of having set our stall about why we're so interested in this and what we'd ideally like to see as a solution, I'm going to hand over to Mike.
Thanks very much for that, Clive, and really appreciate it. And thank you everybody for attending today. So I'm Mike Cooper, and I'm sort of the initiator of this project that's been going on over the last couple of years or so. I'm just going to take control of the slides there. Okay. So I'll give a shout out again to the value of the Innovation Festival, and this is where it started. We'd been working with the European Space Agency, and we jointly funded a daily dash together to really get to the nub of some of the challenges that the water and some of the gas supply utilities that were there were facing at the time. And in addition to the challenges of leakages, which I'm sure everybody on this call is sort of working on, one of the biggest challenges that came up that was growing in concern was the subject of third-party buildovers or third-party infringements. And those developments happening within close proximity to those strategic networks was becoming of increasing concern. So we initiated some work with our partners, Geospatial Insight, who are satellite and change detection experts, to really think about how we could address this problem by using available satellite services to monitor the networks on a more frequent basis. And we made the case to the European Space Agency and the UK Space Agency and managed to secure €500,000 worth of match funding to test the technical and commercial viability of this project as part of a 2-year project plan part funded by the European Space Agency. So this is the sort of journey that we've been on. And picking up on Clive's point and the rising challenge, if we're truly going to build 300,000 new homes per annum, a lot of those homes are likely to be built into those infill sites. And the reason that those infill sites have not been built on is quite often they're the entrance to where utilities service the estates. So one of the examples there that Clive showed earlier, was a case in point really of an infill site with a developer saying, oh great, I can get a few houses in there, and not realizing the reason it hadn't been built on is because there's sort of a 4-bar strategic water main handling underneath that site. So with considerable house building programs, there's 2,000 infrastructure projects taking place at the moment with a value of more than 10 million. And again, these are the sorts of causes of the challenges and accidents that we have. And as a result of lost supply, the regulatory impact as a result of those outcome delivery incentives is estimated to be around £150 million per annum at the moment. And going on to the left-hand side of the slide, working with Northern Gas Networks, who currently are regulated to fly the line with helicopters every 2 weeks, what they're saying is that over their network in the northeast they're finding roughly about 50 infringements for every one of those 2-week passes that they run with the helicopter monitoring program. And obviously the cost of that is significant. There are estimated £72 million worth of carbon cost amounting to 300,000 tonnes an annum at a time when we're being asked to think about our commercial and environmental impacts. And that impact, going back to the human element of this is an event that happened not that long ago in 2023 in Nottingham. And a couple 6 months after the flood, still unable to re-enter their homes. And although Clive's said that quite often those costs can be recovered, well, here the firm behind the water pipe damage has gone into liquidation with 1.5 million owed. So who picks up the bill there? And this is obviously a very recent event, just to highlight the challenge that many water utilities and gas utilities are facing. So working with Northumbrian Water and Essex and Suffolk Water, we've developed IPAS, Interruption Prevention Alert Service, which is an automated location-based risk alert tool that continually monitors the network and mitigates risk from third-party interference right across that network or the size of the network that the customers decided they want monitoring. And looking at the particular risks that we're aiming to address here, so this has come from a point of view where we're really focused on the problem. So we don't have a solution looking for a problem to fix. We're really focusing on what are the problems and the risks that we're aiming to address here. And the key one, as intimated by Angela and Clive, is that customer service and supply risk. And obviously that's one of the areas of key concern for the regulator as well. And obviously, anything that we can do to mitigate those interruptions has significant benefits to your customers. And that then leads on to brand and reputational risk. And we've sort of seen the impact recently of discharge into rivers and seas and the reputational risk that's caused with increased public awareness on the reputation of water companies. And again, if we can mitigate those risks and stop them from happening in the first place, it obviously, and the fact that you can promote the fact that you're you're working proactively to avoid those risks, then that obviously has huge reputational impacts. The financial risks we've touched on. It's not just the outcome delivery incentives that are at risk, but obviously the cost of remediation and putting those right, especially if the third party that's caused those problems is unable to fund the damage that's been caused, or unable to move the pipes or forgo the development that's in place. Environmental risks. This is something that came up recently on two folk. Obviously, there's one with the flying programs, with conventional methods of monitoring with helicopters, but also environmental risks such as fly tipping and discharge from unknown third parties, and the ability to monitor and track any changes that might be a cause of some environmental impact on the network. Of course, there's health and safety risks at all time through that third party interference, not just to the operators, but also to the public. And then finally, regulatory compliance. And I think, as we're heading towards an election, I can certainly see more rigor and more pressure placed on the regulator to improve the relationship between the water companies and their customers from the regulator. I'd just like to touch a little bit here on MGISS as a business, and the fact that we've been helping water and gas and other utilities both capture and manage their asset information to a high degree of accuracy for a number of years now, including Northumbrian Water Group and Essex and Suffolk Water. And IPAS is one of a number of services that we're launching to help organisations really leverage that investment that they've made in the capture and management of those assets, which is often seen as a cost centre, to really drive a value centre where that information can be used, and especially when combined with AI and machine learning and analytical capabilities to improve the performance of those networks. So IPAS is one of those services. We've obviously got 3D visualization tools that more organizations are using now to visualize their hidden networks using I can't think of VGIS, augmented reality is the word I'm looking for, and obviously GIS analytics as well. We're an Esri partner, and obviously the GIS capabilities also allow organisations to really develop those insight services and leverage that investment in the capture and management of those assets. Just like to touch briefly here on how this change detection service works. So with our partners Geospatial Insight, we've identified, working with the utility, what part of the network are strategic and what part of the networks need monitoring, and then we're able to use daily satellite coverage to identify any changes automatically. So this isn't somebody eyeballing those satellite pictures. This is a pixelation change that says something's happening here that you need to be aware of, because it suggests that change is happening on the ground. And obviously, as it passes over a few more days, we start to build confidence in that. So at the point of which we say, hey, something's happening here that we need to inform our customer, IPAS customer, that they need to go and have a look at something here. So in simple terms, we've got a buried water main crossing open land. We've got that automatic change detection going on with the satellite services. If there's any slight changes there, as we can see here with the pixelation, it automatically picks up that, something's happening here that you need to be aware of. The next pass, confirms that. And what we do is we send out a risk alert to the particular water utility to let them know that something's happened there and perhaps they need a field inspection, and we provide the process to allow for that field inspection and resolution to take place. So this is a real risk to resolution solution that we're promoting. It comes in 3 stages. There's the change detection stage, which monitors specific areas. So this is a consistent monitoring service. So it's not just a 2 weekly fly past with a helicopter or a walk the line every 18 months to 2 years. This is a consistent monitoring service with satellites passing over on a very frequent, often daily basis. That then is managed within our hosted insight service, IPAS, as the framework, which sort of says what we're monitoring, and also manages the little bits that say we're already aware of areas, so we don't need to inform the customer because they're already aware of developments taking place here that aren't a risk, or those risks are being managed, so we can take those out the picture. And then we've obviously got the supply of that risk to the customer on a batch setup, and then obviously we've got the field inspection operation as well, and resolution process as part of that. An example here of the sorts of satellite changes that we're getting. So this is a development that the customer knew about that we wanted to use as part of the initial feasibility and technical feasibility testing. And what we can see here is a number of changes happening over from that automated detection from the satellites over a particular point. And we run this across 7 locations in the Essex and Suffolk region, and our algorithms picked up all 7 of those test area changes. So it gave us great confidence to the extent that Essex and Suffolk Water were able to promote this with us to the European Space Agency at the first review, and now we've got a further level of funding this year to run a pilot at Essex and Suffolk Water, following the successful conclusion that we could demonstrate that IPAS is both technically and commercially feasible to the satisfaction of the European Space Agency and the UK Space Agency. And the UK Space Agency's main goal here as well, obviously they are a funder to the European Space Agency, is that if we're going to have a major building program taking place, that I think the UK Space Agency want to demonstrate the value of AI and satellite capabilities to help support any government with those changes to the building programs that they would like to implement post any strategic election changes. So I'm going to hand over to, hopefully that's been useful, I'm going to hand over to Darius now, who'll hopefully be able to take you through the more technical aspects of this solution.
Morning all. It's Adam. Thanks, Mike.
Oh, sorry, Adam. Sorry.
That's all right. Someone could just pop up the video for me, please. So I'm the Strategic Network Manager at Essex and Suffolk Water, and I'm just going to have a quick run through on how we're currently using the IPAS system. So IPAS constantly monitors an area that's predefined by us at Essex and Suffolk Water. If you just pause it there for a second, please. As Clive alluded to, with hundreds of kilometres of strategic mains and assets, it's impossible, even with an army of resources, to be able to monitor all of their assets at the same time. IPAS provides the ability to do that with those predefined areas and to alert us when infringements are identified. If you could carry on playing the video, please. So when a risk is identified, we're alerted via an email from the MGISS Risk Alert Service. We're currently receiving them as a batch. We can now click on that link. It takes us into the dashboard where myself or a colleague would look to interrogate each one of those TPIs. So there's a list of the TPIs to the left there where we've got unvalidated TPIs. And you can see in the example, by using that slide bar, there's something that's changed at that particular site. So we can then make that decision to dispatch this to a field operative. Again, that's a straightforward sort of process. So we would edit the TPI. We'd decide who we're going to dispatch that particular activity to, give it a priority and a due date, and then send it to our field operative. If you could just pause it there for a second, please. So with the TPI that's been dispatched, the field operative will receive an email. That email contains a link to the Survey 123 app. This allows our field operative, if you could carry on playing, to view the TPI, but also to navigate directly to it. As you can sort of see, if you just pause it there, that as you was to move towards that TPI, you'd actually see your location, because you're not always going to be able to drive to these specific points. You can just carry on playing, please. So once on site, the investigations can take place. Notes can be added to this particular TPI. So what was seen on site. So we're noting that construction work has started. Photos can be added. And then these would be returned to the office. As this particular TPI was sent back as a high risk, it would actually create an individual, a specific report, because we're saying there's a high risk. Again, within this report, there's another link to the dashboard, but there's the examples of what the TPI was noted, and then the pictures captured from site. So again, back to the dashboard. So these are now our validated TPIs. Again, you've got the examples of what was captured on site. And in addition to that, you've also got the orientation of the photos when they was captured on site. And then it would be down to myself or a colleague to then decide what action we'd be taking next. Thank you.
Thank you, Adam. That was great. Yeah, delighted to be here this morning presenting to you. And I'm going to take a few minutes now to go through the technical approach. Hopefully this won't be too painful for everyone, but I'm going to start with the core requirement, really. So a very straightforward requirement. The network manager is to be alerted of ground change due to third-party interference within 50 meters of the network. But first of all, I just need to describe how we conceptualized and built that system at a very high level. There's three components. So the detection engine. So this is the satellite observations that are creating the TPIs, or the third-party interference items. The alert engine, which generates the actual alerts and sends links to the dashboard that Adam showed there in the video. And finally, the field inspection and reporting component. So in preparation for IPAS, the user simply provides a geospatial area of interest for us to monitor, and that kicks off the project. Okay, just a few slides now to go through that technical approach in more detail. Following those three components, just break that down a little bit for you. So first of all, working with our partner Geospatial Insight, the decision about the imagery service was taken. So PlanetScope, the 3-meter optical imagery was ultimately chosen over other services, and the freely available Sentinel-2 was also considered, analysed, but ultimately dismissed as the 10-meter resolution did not allow us to detect the right kind of change. Also, frequency of pass is really important for capturing the right change, especially in a cloudy country, and the Dove Nano satellites capture the entire planet daily, actually, and sometimes more than once a day. So SAR, which is synthetic aperture radar, different technology, of course, was also considered due to its ability to penetrate cloud, but again, ultimately, once everything was analysed, ultimately dismissed when performance and cost were analysed together. So in terms of the engine itself, again, working with GSI, the Earth observation engine analyses the satellite imagery cropped to the area of interest for evidence of the removal of vegetation and breaking ground, which are typical prep activities prior to construction. So 5 change detection techniques are used, and if 2 or more of these are met, then a ground change incident is prepared for the alert system. So the more the merrier in terms of these techniques, and this value in terms of confidence level is rising in line with a number of these indicators. Okay, so the alert service, powered by FME, feature manipulation engine, FME cloud, in fact. So TPI locations are received from the Earth observation engine. And this triggers a new point added to a web map and an alert sent by an email to the network manager. So FME Cloud was chosen as the incident processing engine. It's a flexible, always live service. There's power to carry out these complex GIS and imagery processing, as well as automating the creation of alerts and those reports that you've seen as well. In terms of the front end, the user experience is kind of dominated by this GIS dashboard. So it's an ArcGIS Online powered web app, which allows the network manager to manage these potential network infringements. And key to this are tasks such as TPI analysis, validation, and reporting. Now, if the TPI or the infringement cannot be validated back in the office, maybe it's not clear what's going on, or it obviously needs someone to check it out because it's an obvious change on the ground, then it can be dispatched from the dashboard to a field operative for on-site inspection. Okay, so approach 3, we're looking at the field inspection. So the field inspector receives this email alert and can initiate the inspection via an embedded link to the field app. And this field app was in terms of choice was Survey 123 and has the capability to deliver on several field to office requirements. First of all, work scheduling. So the app Survey 123 handles the required work scheduling via the inbox function and filters those assigned infringements to the field user. So real-time results, so it's been configured to capture the required field evidence, and as soon as the result is submitted, will be available for the network manager in the dashboard. If the field user is offline, that is also supported by an outbox. And finally, webhooks and feature reports configured together, powered by our data processing engine to produce those live reports as soon as they're submitted in the field, meaning that those high-risk TPIs are triggered instantly and brought to the attention of the network manager straight away, and anyone else who needs to be informed. And I believe that's the end of the tech session. I'm going to pass back to Leah.
Thanks, Darius, and thanks to all the speakers so far. So we're just going to go to a quick 15-minute break, give you all a chance to get a nice drink, and come back in time to hear some more about some learnings behind the project and the sort of future opportunities for MGISS, which will be really exciting. So Following that, we'll be going into the question and answer session. So as my colleague said at the beginning, feel free to just keep popping any questions you have into the chat throughout the break and throughout the Q&A as well. And we'll do our best to answer all of the questions.
Thanks, Leah. And welcome back, everyone. We had a nice little break, and we're going to, without further ado, move to the lessons learned section. Okay, so what have we learned? Having completed a 6-week period of UAT, user acceptance testing, the feedback has been very positive. The potential impact on the business and third-party ground change, both risky and not so much, has already been detected on the network that without IPAS, it wouldn't have been, till much later likely. So we now just commenced the pilot phase, and this is going to run through to November. Okay, so lessons learned. So first of all, ground change confidence levels. So first of all, a reduction of false positives such as plowed fields, patchy clouds, stationary traffic, and other image artifacts like those caused by shadow, passage of objects such as planes has been key to improving those confidence levels. And the image you can see on the right is a pre and post flyover that shows an artifact in the second image, which is obviously a false positive. The brightly coloured object there, likely a plane or something like that passing over. So these are the kind of things that we need to that we've been concentrating on removing from the system. Obviously, proximity to the buried pipe is also significant. It's not a massive factor because obviously construction sites can very rapidly move, but that the initial position of those sites is also taken into account now. And then finally, satellite image misalignment. So the pre and post imagery positioning has sometimes been found to be inaccurate, and that can trigger false positives as well. So we also, with GSI, have been working on pre-processing the imagery realignment, and that's going to correct that. So what's the result so far? So that a more reliable confidence level and fewer false positives. But this calibration process is continuous. We're constantly adjusting and tweaking those confidence levels to make a better product. So TPI management, so that the management of these third-party infringements, the current way of creating these reports creates constantly shifting GIS polygons of change, and these are proving difficult to manage, especially where those change polygons overlap. And we're currently testing a new hexagon-based detection and monitoring system, actually based on the Uber H3 model, which will add some consistency and reliability to this process. Also, being able to monitor change over a consistent area will have the added benefit of tracking change consistently over longer periods, and that will help us to create land classification and again ultimately leading to improved and more reliable confidence levels. Okay, so moving on to the back office enhancements. So what have we learned there? So early on during the user acceptance testing, having access to those satellite ground change images georeferenced in situ on the dashboard, like you'd seen in the videos earlier, would help the back office user, the network manager, decide whether to dismiss or dispatch a TPI to the field. So obvious false positives can be spotted earlier, providing a more efficient workflow. And that's now been implemented with this simple, intuitive layer slider to take you from the pre-image to the post very quickly. And that will essentially help the network manager, and we will be also delivering some training on basic satellite image analysis along with the onboarding. So also it was determined that assessing field operative feedback would be improved with some indication of the position and direction of the operative when taking photos. So, and now we're using oriented imagery to help with that. So it really helps to know where that operative was stood and what direction he was facing when he took those photos. And finally, system and data integration. So have improved the viability and usability of the IPAS front end as a standalone product in the customer setting. Users are now interested in integrating IPAS with their corporate asset management system, and that's IBM Maximo, to basically to embed that product as a BAU, so it becomes normal for them. This will leave the benefits of streamlining the current business processes such as works management and bringing into an element that feels more natural to the wider business. As part of the prototype GIS front end, we decided to use an open API to enrich the experience planning applications for the pilot area. The idea is that in some instances, this will enable the asset manager to pair ground change with build applications. And the value of this data service was really obvious from user feedback, and we therefore plan to explore this as a permanent managed data service along with others, such as you can see on screen here, which is a snapshot of one network, a live roadworks API. All right, well, I am going to pass back now to Mike Cooper, and thank you for listening.
Thank you very much, Darius, and thank you very much to Adam as well for your great explanation of the technical aspects of this project. I'd like to start with, obviously, in terms of future developments, the first point of this is obviously, there's a business behind this and the need to commercialize the offer. And part of the ESSA point was that we have to demonstrate that there's this is commercially viable as well as both technically viable. So we're currently looking at the costs of monitoring a network, and obviously the data costs are a significant part of that, as well as running the platform and continually improving the service offering. And we'd estimate at the moment that it would be around £250 kilometre of network to monitor. So we'd provide a monitoring network for £250 kilometre network per annum. So that would be equivalent to around 250,000 per annum for a typical water utility managing 1,000 kilometre of network, such as which is slightly just under that at Essex and Suffolk Water. We'd expect those costs to reduce over the longer term. Data costs are coming down as more satellites are being put into orbit, and we'd expect that continual reduction in the cost to purchase that data. And it's something obviously we've been working with PlanetScope on in terms of scalability, and if we managed 50% of the UK, what would be the cost reduction for us? So as more customers come on board, we'd expect not to increase that cost each year, but to reduce that cost each year as the costs come down and more customers come on board. However, talking to the gas utilities that currently fly those programs and the current cost of walking the line and other methodologies, we believe this presents a significant financial cost and carbon cost advantage over the alternatives. With many added benefits about the repeatability of this particular solution, and obviously as well the provenance to support that regulatory compliance. At the moment, those helicopter flyers use a piece of paper, with a rough estimation of the map. What this does is actually give you that provenance and the date as to when these changes were happening, as evidence for any future discussions. Some of you may be asking, what does it take? You know, what would we need to do? Because you've already mentioned that obviously you'd have to have some sort of record of where your assets are that you'd want monitoring and what defines your strategic assets. So what we've done is sort of set up a 5-stage process. The first one is obviously we come in and have a look at a quality assessment of your current asset data holdings and look at the areas that you want to monitor and obviously the corridor either side of that you'd want to monitor to avoid those third-party interferences and infringements. We then look at satellite imagery. So once we know the size of the area that we're monitoring, we can obviously work with PlanetScope and with Geospatial Insight to look at the procurement of those data services. We've obviously got your front-end system set up. Any integration with the existing systems, such as IBM Maximo, and then user training. So we believe that we could onboard within about 10 weeks. And those onboarding costs, obviously, we'd think about an average of somewhere around between £25,000 and £50,000 for that onboarding cost as a one-off charge. The future developments, as Darius has just touched on, you know, the fact is we're using AI and machine learning to continually calibrate those algorithms. So we're looking to continually improve the accuracy and the reliability of any changes that we add to reduce the number of false positives, etc., and to start to pick up areas such as one of the points that was mentioned was illegal access to the network. Could we start tracking, you know, a development of a number of caravans? Because we, you know, from the experience in the gas sector, tapping into their networks illegally is a major problem, and anything that we can do there. We've obviously already touched on from a from an environmental perspective, dumping of waste by illegal means as well, and anything that we can do to identify that growing problem of fly tipping. The inclusion and integration of planning data. I'll show you a slide at the moment. So we've actually started some work on that, connecting straight to planning data services. I don't know if anybody is aware of the National Underground Asset Register. So, you know, how would we integrate? And we've already started some discussions with NUAR as to how we'd start to integrate with NUAR Underground Asset Register services, and perhaps the integration of leak detection data and other risk services, including flood risk services or flood risk to assets. We've already put some thought into the IBM Maximo integration. I won't go through this. It's not, you know, but I think it's just to demonstrate that we've already started discussions with Essex and Suffolk Water to use their existing IBM Maximo to replace the field inspection system that we've developed during the pilot to integrate with their own IBM Maximo field inspection systems. Example here of planning data. So we've already started to connect through to the Bristol planning data web through open APIs to add, again, some validity and some confidence to when we're finding changes as to whether at some point there has been a planning permission. The reason that we can't use planning permissions as the main point is because it may be that somebody asks for planning permission and they might not build on there for 5 years, or they might not never build on there at all. And also we've got unauthorized developments where no planning permission has been sought, and the impact obviously of those unauthorized developments. But we believe that the planning application data will add another dimension of reliability and service performance. And then this is a final call out here to say, you know, if you would like to get involved, we're going to be at the Innovation Festival from the 8th to the 11th of July. And if anybody would like to start engaging with us or to start talking to us about how we could extend pilot into your own particular water utility for perhaps a pilot setup, then please come and talk to us, and the links are here. And we've also got a roundtable discussion planned in the future in conjunction with the European Space Agency, probably at the tech site in Dursbury, which is really interesting if some of you would like to visit. So please, again, please come and see us at the Innovation Festival, and also register for our roundtable discussion if you're interested in taking this further within your own particular utility organisations. So I'm going to hand back to Leah now.
Thanks, Mike, and thank you to the team so far for a really interesting presentation and some lessons learned there. That's great, thank you. If all of the sort of panel and presenters so far could all just pop their cameras and mics back on, we'll now go into the Q&A session. Thanks, Mike. Thanks, Adam. Darius, perfect. Okay, so some questions that have been sent to us privately, first of all. The first one I think is for Clive. So you mentioned monitoring the critical infrastructure network. How do you define this, and what length of network can be covered by MGISS? Can we, the customer, define how much is covered by MGISS, and can we change the network to be monitored?
Okay, so taking those apart in turn, that was quite a lot. The first one was around how do we define what we consider to be the strategic network? Well, at Northumbrian Water, our GIS system has a flag on it actually against water mains that are considered to be strategic. And essentially, the method of arriving at that was to say, well, we'll consider anything over a certain diameter carrying a certain volume of water to be a strategic main because it's clearly delivering water. But then there are some other categories where our subject matter experts, people like Adam, have been in and said this piece of main, for whatever reason, would be considered to be, you know, critical to operation. Its criticality would warrant it being strategic. So that's how we do that. They're simply flagged, and then identifying the strategic main and measuring it is a simple case of doing a query on our GIS system. So the length of network that can be covered by IPAS we understand to be unlimited, as long as it's covered by satellite imagery, and that, you know, it's up to us what we determine. And at the moment, what we've done at this stage in the project is to identify a section that we would like to monitor, with a view to gradually expanding that out and demonstrating the return on investment to our board, allowing us to invest and produce some, you know, statistics as we go along about how much we think this has saved us in the various categories of value. The strategic network is defined by us, not by our customers. So that's that one. Can we change the network to be monitored? Yeah, my understanding is absolutely. Perhaps Michael Darius can confirm this, but our understanding is most definitely that we can just say, yes, tomorrow we'd like to switch on this new part of network and perhaps switch off this area over here, which nothing ever happens on, or we were mistaken by monitoring it. So it should be, and that was, you'll remember when I opened, one of the desirable things that we would like is flexibility to choose from a desktop which parts of the network are monitored and not monitored.
Yeah,
absolutely.
Does that cover it all?
Yeah, can I answer that point that you made, Clive, about the monitoring? Obviously, we've got to work with PlanetScope, because what we're doing at the moment is saying, right, this is what we want to monitor. So we'd obviously have to set up a process to say that we're no longer monitoring this area and we now want to monitor this area. But that's a simple process to set up with PlanetScope as a data, and with Geospatial Insights as well.
Perfect. And just to check, Mike, there's no sort of limit to kind of how often you can change what areas you want monitoring versus not monitoring?
Obviously, there are some administration costs involved in moving those areas, as you'd imagine. So obviously, that's why the importance of the onboarding and working with the customer to say, just, you know, what is strategic, because obviously we'd be looking to change that no more than once or twice a year, ideally. But it could be, if somebody says, look, there's kilometres of section here that we're paying for that is just no interest, we'd like to swap that over for that, or just take that out, then that's not a problem.
I should say that's unlikely as well, that approach. It's much more likely, and we think the way it will go is that we will designate an area and simply increase it up to the whole strategic network, because that's what we want. We want the entire network monitored all the time. So, you know, why would we remove anything? You know, anybody can build anything at any time is basically the premise we're operating on here. So we need to watch the whole network.
Yeah. Just to add to your point, sorry, Leah.
No, go ahead, Adam.
with our strategic asset, as Clive's already alluded to, you know, these are large diameter mains, and we're not replacing them left, right, and centre. So the likelihood is, you know, we're not going to be looking at changing that on a weekly basis. You know, these would be large schemes, and you know, we'd only be amending those corridors on, you know, maybe it's something that we would look at reviewing annually. But again, a lot of those replacements are likely to be within the same corridors if you're replacing something like for like. So,
absolutely.
It's worth pointing out as well, anyone listening outside the UK, obviously our data services are global. So yeah, the system will work anywhere in the world.
Yeah, on that point, actually, I've started some discussions with the Colombian government, and as well through New York and the World Bank in Rwanda as well. So both, it is interesting coming from, you know, areas that we just wouldn't imagine, where, you know, Colombians have said they've got exactly the same problem with their third-party infringements on the network. So yeah, so we've already got some international interest out of this. Yeah,
perfect. That's great to hear. So then, was the kind of method at Northumbrian Water to find almost like a highest priority area of the network that was kind of consistently being impacted, and then that was kind of where you started and have continued to expand from there?
There is no consistency in this, and that's the nature of the problem. Okay, so you don't know what you don't know, and it could happen anywhere, literally, in urban or rural areas. So what we did was Adam and I discussed very carefully, you know, an area that it was within a range from which his team could service and inspect easily, and are already, you know, operating in, and agreed a size and scale to start with. That's how we chose.
Okay, perfect. Thank you. Okay, so next question, I think, is for Darius. Can you be sure that the technology will be able to collect the satellite imagery frequently enough, and how often is it collected?
It's a very good question. So we collect, well, the service that we've subscribed to collects the data daily. And yeah, it's obviously a great challenge, especially with the summer that we've had. You know, that getting those cloud-free days to detect changes is obviously difficult, but the performance has been better than expected. You know, even if we're getting an image, you know, a couple of images every fortnight, you know, at worst, that is often enough to detect the kind of change that we want. You know, a construction project that started in that period, we're going to capture it. So fairly sure that we are getting the right frequency. Yeah.
There's a sort of end user perspective on this as well, which is you could do this too frequently. For something that we could handle. So what we've got to do is test the water and experiment with the slider bar up and down on frequency on how responsive and reactive we can be to what's coming out of the system. That's one of the unknowns. We don't know how many alerts there are going to be when it's fully operational.
Yeah. And obviously we're assigning confidence levels to these alerts, so we can filter them by priority as well. If we've got you know, 3 high priority and the rest are very low, then we can, you know, focus on those. It's also worth pointing out that Planet are planning to launch a new constellation very soon as well, so we're likely to get you know, a couple of passes each day at that point, at least. And even if we only get an hour of sunshine in that day, there's a better chance of hitting that window wherever we are at the right time.
We realized very early on that we would need some form of confidence factor in the alert, in the warning, so that we could go to what appeared to be the highest priority, the most likely to be third-party activity incidents, rather than waste time on lesser ones. So they're not all equal, and there are a number of factors that go into determining what the confidence factor should be, and probably one of them, I don't know actually, but probably one of them is the quality of the imagery, the amount of change that's occurred over a period of time. So that I'm sure they're all factored in.
Yeah, and also proximity to the centre of the pipe as well. It's that kind of thing is factored in.
Yeah,
Darius and Adam, didn't we find during the pilot? I mean, we've only been running the pilot a short time. Found our first interference.
Yeah, well, there's been a number of ground change reports. There was one very recently, I think, that was flagged as risky. So yeah, we're following that up. Well, Adam and his team, if you want to add anything to that.
Yeah, well, there's obviously been things that have been flagged up where we've had a TPI come through, and we've done that desktop validation, and we decided not to dispatch someone because it is a development that we're aware of. So again, that gives us that choice to, because we know it's something that's already got plans afoot. You know, we can park that to one side, but it also has identified some occasions where there's been a development that's been picked up through satellite imagery. It is away from our asset or somewhere where legally we can't stop anyone doing anything. It's outside of our easement, as an example. But it's that engagement piece with that developer regarding having to cross our asset and so on and so forth. And yes, we have had examples of that. So yeah, it's been a real positive.
Thanks.
Oh, that's great. Thank you.
We were a little bit, I suppose, concerned about the accuracy of the alerts that will come out, and we were wondering how many false positives there will be, you know, in the early days where we went out. One of the beauties of the project is it's learning all the time. So every single instance you look at and the decision you make about, no, that's nothing to worry about, or yes, this is a very high priority. The system's like a sponge. It's learning all of that so that future predictions, future confidence factors become more certain. So
that's brilliant. So it's kind of getting smarter as it goes on.
We're going through the pain for everybody else basically by doing this, you know, because by the time other people get their hands onto this, we'll have been through quite a lot of that and ruled out the obvious stuff.
Yeah, amazing. So you've kind of been the guinea pigs that everyone else can benefit from.
Yeah.
Amazing. Okay, great. And Clive, what would you kind of say the return of investment on a project like this is for Northumbrian Water?
That's a great question. It's incredibly difficult to answer though, because like assessing the benefits of doing things to avoid utility strikes, you know, it depends how serious the strike is and what the overall costs of that are that you're saving. It depends whether you're actually averting that or not. And in many cases we will avert it, but you'd have to predict what you might have spent in across all of the various areas, from, you know, just repair through to you know, managing the reputational aspects, the legal costs and so on. We'd have to assess those. So what we're thinking at the moment is that we monitor very carefully, and actually it's chicken and egg. We can't produce a compelling business case up front. We need the data, we need the system to show us all of the places that we're going to discover over the next few months, and we're going to avoid costs in those areas and possibly penalties. If we were to have an interruption to supply, you know, it could result in a penalty. So we will monitor it over a period of time and build that case with evidence behind it, and we will have to come up with some standard models of what the impact and cost would have been had this turned into a utility strike, and B, just, you know, somebody had built something and then we had to go through the process of either redirecting a main or, you know, going through legal wranglings or whatever. So that's our intended approach.
Absolutely. Yeah, no, that sounds great. Thank you, Clive. So we've had a question from Tom in the audience who would just like to know, I think it's a question for Mike, I think you've already touched on this, but is there potential for this to be used in the future to support local flood risk management beyond the focus on strategic water mains? So sort of including your sewers and things like that. And have you engaged with any local authorities responsible for managing surface water flood risk?
No, what we have done actually, Tom, is early on in the process when we were looking at problems, we looked at assets as a result, and we looked at the River Dee. There was a flood on the Dee further up towards the Welsh end. That was an impact, and then we looked at, you know, how we could have used the satellite imagery to monitor and change that. So we have touched on that, and we're confident that we could deliver that. Once we know where your assets are, then we can bring on board a number of risks. And I think the key one about that is that once an area is under flood, it's very difficult for the operators on the ground to find out where the relevant valves are to go and address that problem. So by having that high quality data in the first place as well, it means that you can go straight to that valve rather than feeling it around for you in your bare feet, which I think has happened in Essex and Suffolk on a cold January day a couple of years ago. So yes, we do see potential for the ability to bring in flood data as part of a future service.
I think that's a great question to ask, Tom, and it's kind of a natural question that follows on from this. If you can apply this approach for this purpose, how, you know, what other problems could you apply this to? And you know, at this stage, it looks like it's really good at doing this kind of monitoring activity on distributed, very large and very long things that are in a narrow corridor. So, you know, that could apply to all sorts of things. This is superb material for an innovation festival sprint. I wish we'd put on a sprint to sort of say, I think maybe next year, once we've proven it works and we understand really fully the pros and the cons and the difficulties and the challenges and hurdles, that we then consider other use cases that we could apply this approach to.
Absolutely. So there's definitely a plan within Northumbrian Water to kind of expand this into sewer networks as well, and kind of use it.
Well,
as
I wouldn't say there's a plan. What I'd say is we're very open to exploring other applications for it. I wouldn't limit it at sewer networks. There are probably all sorts of linear distributed problems we could apply this to, and not just in water either. You think about, you know, power, gas,
rail.
Yeah, rail, exactly. Anybody who's got that kind of asset, then they probably got a problem that you could tackle with this.
Absolutely. No, that's great. So it's absolutely a massively versatile, sorry, I can't speak, versatile product then in that case. Absolutely. So next question from Wheat is, in the demo video, the resolution of the video does not seem high enough to capture urban third-party activities. Are you looking to do further tests in a highly urbanised area, and what will be your approach?
I'll take this one if you want. Yeah, thanks, Wei. Great question, actually. So we are planning to test in a variety of environments, because we are fully aware that, you know, in different countries, the layout of the strategic network can be very different. You know, more network on the highly urbanized environments and others as well. So there's plenty more work to kind of maybe globalize the product. But the Essex and Suffolk pilot area was also chosen due to its variety of environments that the network passes through. So it's not just rural areas as well. Those very close to roads and through residential areas and things like that. So we are you know, constantly calibrating and tweaking the performance of the system, and it may be that it varies slightly different in the algorithms that work in other countries than those that run in the UK. But yes, so we are using a 3-meter resolution at the moment, and we are finding that it's working in the pilot area.
Yeah, I think to add to that as well, on the 3-meter resolution, with the tests that Geospatial Insight did, it was the optimal level for actually finding change. Because if it's too small, somebody putting up a tent in their back garden as a temporary feature, or somebody having a wedding, and it was, what we did on the testing, actually 3-meter resolution provides, I think, the level of confidence that we needed to say that there's change happening here. Although it might not look as accurate as perhaps a 1-meter resolution, it was delivering less false positives than a highly accurate data set.
Yeah, and obviously going higher in that resolution obviously massively pushes the cost of the system up as well. So we've got to hit both the commercial and technical viability, which is what we've done here.
No, it makes a lot of sense. Thank you both. That's actually really interesting. Obviously, you'd assume the clearer the picture, the better the program's going to work. But what you said about sort of tents and temporary changes, that's something that is really interesting, actually. So thank you for that. Okay, and Tom just wants to kind of add to his earlier question. So he put, thanks both, that was a really useful answer. Related to the above question and open data agenda in the water sector, could this data, in brackets, potential third-party interferences, be shared with other risk management authorities, or are there obvious barriers to this, for example, commercial model?
I'd say I'd term it hurdles rather than barriers. I don't think these are insurmountable problems. The current model is aimed at asset owners, and I assume what we're talking about here is non-asset owners who would nevertheless be interested in this kind of activity going on. And you can imagine, say in a region like Essex and Suffolk, if gas and electricity, maybe the local authority or the local lead flood authority, were each taking out the service, you have strips of land that were being very carefully monitored, and you build up a picture with dots all over it of actually there's something going on here, which from a planning perspective would be really useful. So I suppose at that point, when there is critical mass in uptake, then there's a dialogue to be had with other people who are not asset owners and consumers directly of the service, because they've got something in the ground they're trying to protect, and it's more a awareness of things that are going on that could affect their line of business, whatever that is. There's certainly a dialogue to be had there, I think, and an exploration. It's a very good point.
Yeah, I think framework agreements would work with this quite well. I think once we've got that critical mass, as Clive said, it is working with either a government department or a number of utilities together, or a number of local authorities, to say, we could provide a framework service with commercial limitations if it's not being used for commercial use, is something that we'd obviously want to we'd be open to look at. But again, it's subject to we're a micro SME developing this idea. We've obviously had funding through the European Space Agency and the support of Essex and Suffolk Water and Northumbrian Water Group and Northern Gas Networks while developing this. But at the end of the day, we have to make money to keep these projects going. But our focus is on delivering that resilience to those customers that we work with.
Perfect, thank you, Mike. So Darius, another one for you, I think. Is the platform a standalone one? So if a customer has an existing system that they use for work scheduling, could your platform be integrated with that?
Okay, yes, two separate questions. That's yes and yes, essentially. It is standalone. It's been built as a standalone system right now, so anyone can, we can scale up and deliver that within a few weeks, really. So yes to that question. And in terms of integration, we have done some exploration of integration with Northumbrian Water's asset management system already. So we have factored that in as a task and a capability to the system as well.
It's really interesting that the way the system developed was that Darius and Mike were periodically bringing to us versions of the system as it evolved, of the platform as it evolved, and it got to a point where they almost went too far and they had delivered too much. They guessed how we worked and how we would want to dispatch stuff out into the field, and at that point we said, right, you just crossed a line between what we would want to feed into the corporate system, because we already have a well-established scheduling and work planning system. So that's when we started discussing integration and how we would integrate, so that there were parts of what had been developed, the smartphone app and the way things were presented and the collection of the information, that we wouldn't want to reinvent. It was superb, and we didn't really have anything in our existing system that did that. So what we've been able to do, and hopefully this will serve any other future users of this, is take the very best pieces that are not typically found in an in-house work management system and grab those and try and integrate them with the rest of the flow of work out to a team, the assignment to a team, and the updating of the records in the corporate system. So that part's actually worked quite well.
Oh, amazing! So you found it quite a smooth integration then, really?
Yeah, well, we haven't completed the integration, so we're still very much in the throes of working out precisely how that will work. And with all of these things, what you find is you integrate a small bit, and then somebody has a bright idea and decides that actually we could go a bit further than that, or we could use this information elsewhere. And so the integration just grows organically. It's not as simple as just doing a grand plan up front and implementing it, and that's it. And we wouldn't want to do that. We want to be constantly adapting and taking opportunities as they arise.
Amazing, thank you, Clive. Darius, I think another one for you. Is this a hosted service, or do we install it as a new application on our existing environment? And if it's hosted, is it supported?
Yeah, so that's kind of some of that's answered by the previous answer. So yes, it is fully hosted, so cloud-based standalone system. And if we were to integrate, then there will be a process of just making that work with our incident processing engine and making sure we're passing that data back and forth. But in terms of support, if it's standalone, we fully support all the hosted elements that we are delivering, whether that's part of an integration or a fully standalone system. Yes, so we offer full-time support on that.
Amazing, thank you. And on the topic of integration, how easy should it actually be to integrate? Is there any sort of resources in particular that a company would need, for example, sort of software or applications or anything, in order to be able to implement it?
So in terms of what you would need to run the system, it's desktop machine in terms of the dashboard and the asset management interface, and then a mobile device that you can install the field application on, which is just an off-the-shelf Esri product. So that's all that's required at the moment in terms of the standalone.
Perfect.
That answers that.
It's multi-platform as well. Yeah.
Oh,
so
amazing.
and Android and iOS.
Yeah.
And Windows support.
Perfect. And so you shouldn't foresee any problems with sort of field workers being able to access the actual application when they're out and about on the job, sort of thing.
I think technically it's not a challenge. I think the biggest challenge comes from our relationship with third-party systems integrators and how we manage those. So IBM Maximo, if IBM are outsource IT, Essex and Suffolk, we haven't started those discussions yet as to how we'd work, and because obviously IBM would want some say, and I think that's so we're able to deliver this as a standalone system if you don't want that challenge of working with your outsource IT, or when working with your outsource IT, yes, we can integrate as well.
We have a fairly big and capable IT department who are, I doubt we would need to have any kind of discussion with IBM. We carry out all our own integrations. So, that's actually for us is going to be relatively straightforward.
Perfect. And kind of on that topic, Clive and Adam as well, I know it's not fully integrated yet, but how is the integration going at Northumbrian? Have there been any sort of obstacles so far or anything that you've had to overcome?
No, not at all. Hopefully the video sort of said it all. It's just straightforward. We're currently getting our TPIs in a batch. As I said, myself or a colleague would then look at them, dispatch it to our field team, and it's just a very simple thing to use. Someone gets an alert to say they've got an activity, and we give them the time to go out and investigate it. They then capture that data on site, and then and then it's just down to us as to what we decide we do with that information. So integration into BAU, simple. You know, it's not complicated technology. The complicated bit is the bit that, you know, Darius and Mike are having to deal with. But certainly our feedback sessions that we've had, and you know, what I would sort of define as like that end user experience. We've had a number of feedback sessions. You know, Darius or the team have managed to, in some cases, change stuff on the dashboard as we're talking about them.
Oh wow, amazing!
Like the slide bar was a great enhancement. It just makes it easier looking at stuff. And the orientation of the photos, if I'm then looking at a report that's come through, it's not always that easy. Certainly if it's a picture of the middle of a field, as to, well, what way is he that person sort of like looking. So yeah, just really good. It's been a really positive experience for us, and I think, you know, I can't remember if it was Clive hit the nail on the head earlier, where the fact that we're getting that opportunity to request or ask for changes, you know, hopefully we're helping someone else at a later date.
Absolutely. No, perfect. Thank you, Adam. So really nice and simple then is what I'm hearing, basically, which is great. And is there, Darius and Mike, is sort of end user training included as part of the onboarding process? Is there anything particular that the company needs to do to kind of train their end users on this, or do you guys kind of produce the training as well?
Yeah, it'll be a bespoke training package, basically based on the end user, whether they've got an integrated version or the standalone, whether they need training on the image analysis, or they're not interested in that. So we'd have that discussion at that stage and tailor something for them.
It's not a direct answer to the question, but it's an opportunity for us within Northumbrian Water, and that's once we've mastered and we've got some very experienced users in the platform, it's going to be the kind of system that we will showcase internally to other departments in seemingly unrelated, you know, with unrelated challenges, but challenges like this. That's one of the functions of the innovation team that I'm part of. We will want to showcase it as a means of raising thinking about where else could this approach be applied. And, you know, watch this space. We may have a follow-on project which is now, you know, introducing new use cases, the ones that for us are the most difficult because they're so distributed, or perhaps the most costly.
Amazing. Thank you, Clive, and thanks to everyone so far. I think that's the kind of end of the questions that have come in. So unless anybody has any kind of final thoughts they'd like to wrap up the session with, I think that brings us to the end of the session. So I just wanted to say thank you to the audience, to everybody who has taken time out of their day to come to today's session. We hope you found it really engaging and valuable. And thank you also to the team from MGISS and Clive and Adam from Northumbrian as well for sharing their kind of project learnings with us so openly today. It's a really great presentation, lots of really useful information, so thank you for that. I've just popped a poll into the chat about today's session, so if audience members could please take a moment to give us some feedback with that poll, we do find it extremely valuable. And as mentioned at the beginning of today's session, we will be posting today's recording on our Spring platform, along with the written case study, and that should be available within the next week. Any questions that didn't get answered today, although I think we answered them all, will also be uploaded alongside those two. So yeah, thanks again, everybody, for coming, and have a lovely rest of your day.
Yeah,
Bye,
thank you very much, all. Meet you at the Innovation Festival.
Thank you.